Hello friends, welcome back in today's lecture, lecture number 5. I am Dr. Milind Meshram, working as an assistant professor in the Department of Chemistry, CHEM College, Nashik. In the last lecture, we have seen the various methods to prepare benzene. So, we are seeing the preparation of benzene by using phenol. So, phenol can be reduced with the help of zinc under heating condition to give the benzene molecule. In second method, we have used the sodium salt of benzoic acid. The sodium salt of benzoic acid can be treated with NaOH in the presence of calcium oxide to give the benzene. In third method, we have used the acetylene. Okay, so benzene can be prepared by using acetylene by a cyclic polymerization process. Just simply acetylene passed through the red hot iron tube at 873 Kelvin degree temperature to give benzene. In the fourth method, we have used the benzene sulfonic acid. So it's a hydrolysis of sulfonic acid. So when benzene sulfonic acid is passed through the superheated steam, so it gives rise to benzene. So these four methods we have seen for the preparation of benzene. So in today's lecture, we will see the various reactions of benzene. Okay, reactions of benzene. As I mentioned it before, benzene is having 6 pi electrons. Okay, there is a presence of pi electrons above and below the plane of the benzene. Okay, so benzene is having 6 pi electrons. Okay. So this benzene these two structures are in equilibrium. So these are the resonating structure. Although this contains the resonance, these pi electrons are in conjugation. Okay, so delocalization of pi electrons. So these electrons are loosely held as compared to sigma electrons. So that means these pi electrons are easily available for donating. Okay, for donating to the electrophiles. Okay, so this benzene ring serves as the source of electron. That means this benzene acts as a base. So typical reactions of benzenes are the electrophilic aromatic substitution reactions. Okay, electrophilic aromatic substitution reaction. There are various aromatic ring systems and various electrophilic reagents, so which involves the electrophilic substitution reactions follows the general mechanism. So let us see the general mechanism for this electrophilic substitution reaction. ignores the general, means follows the general mechanism in first step. Electrophile will approach to the benzene ring. Okay, in first step the electrophile will approach to the benzene ring. So, which results in the formation of pi complex. This is the pi complex. Okay, this electrophile will approach to a benzene ring to form the pi complex. In the second step, this pi system means pi electrons, means benzene system will donate the electron to this electrophile. Okay, to form a sigma bond, and this is known as sigma complex. Sigma, or you can note it like this, sigma complex. Uranium ion. In the last step, this sigma complex eliminate the hydrogen like this. Eliminate the hydrogen to give the final product, substituted product, plus H plus. So it gives substituted product. Okay. So this is how the mechanism is for the electrophilic aromatic substitution reaction. In first step, the electrophile will approach to the aromatic system, that is benzene, so which form the pi complex. In the second step, this aromatic system, the electrons will donate, okay, this aromatic system will donate the electrons to the electron deficient electrophile to form the sigma bond, and this species is known as sigma complex or uranium ion. In the final step, that is third step, the hydrogen will eliminate to give the substituted product along with the H plus. So this is how this reaction will undergo. Electrophilic electrophilic substitution reaction is the general method to derivative the benzene system. Okay. So various electrophilic substitution reaction, for example, sulfonation, nitration, chlorination, and freon trap acylation, alkylation. So these reactions we can use to derivatize the benzene ring. So we can introduce the various substituted groups into the benzene ring. Sulfonation, which involves the oleum, a mixture of sulfuric acid and sulfur trioxide. So we can generate benzene sulfonic acid by using this sulfonation method. So nitration, which involves the nitric acid along with the catalytic amount of H2SO4. So we can generate the nitrobenzene. In chlorination, in chlorine we can use chlorine to introduce chlorine into the benzene ring in the presence of Lewis acid. Without Lewis acid, this reaction will not undergo. So we will see these reactions one by one. Nitration. In nitration, when benzene reacted with a mixture of CH-3 plus H2SO4 at 40 degree. So it gives the nitrobenzene. Let us have the example. Benzene HNO3 H2SO4 at 35 to 40 degrees Celsius. Nitrobenzene. Okay, so this is benzene. So when benzene reacts with HNO3 in the presence of H2SO4 at around 35 to 40 degrees Celsius, which gives rise to nitrobenzene. So this is the electrophilic substitution reaction. So we will see the mechanism. So in first stage, formation of nitronium, ion, okay, that is NO2 plus. So when you treat the benzene with nitric acid in the presence of H2SO4, it gives the nitrobenzene. But if you don't use H2SO4 as a catalyst, catalyst, this reaction will become very slow. Okay, so we have to have used the sulfuric acid in this nitration reaction. So in the first step, nitronium ion can be generated in the presence of H2SO4. So HNO3, that is nitric acid, plus H2SO4. So we can write this HNO3 like this. Okay. So this reaction is nothing but the acid-base reaction. So in this reaction, H2SO4 is a strong acid which ionizes this nitric acid. Okay. So this is the weak acid. So it ionizes this nitric acid, which gives plus, this is the conjugate base, plus nitronium ion. Okay. In this first step, we can generate this nitronium ion. In the second step, this nitronium ion will attach this benzene. Okay, will benzene to give So as I mentioned it before, this is the sigma complex. Okay, in the last step, that means this elimination of hydrogen will take place. Elimination of hydrogen will take place, so we will get our substituted product, that is nitrobenzene. Okay, so this proton will extract by this conjugated base. Okay, so we can regenerate this H2SO4, which we have used as a catalyst. So here we can get our substituted product, that is nitrobenzene. Okay, so this is how the mechanism is for this particular nitration of benzene. Okay, this is how we can generate nitrobenzene. So when we have generated this, when this nitronium ion attacks on the benzene, so which gives rise to this sigma complex. So we can write the various resonating structures for this particular sigma complex. Okay. 4 structure. So this structure 4, this structure 4 is the hybrid structure of this resonating structure. Okay. So in the nitrogen, when you approach, when this nitro group attacks on the benzene ring, the aromaticity of benzene is destroyed. Here we can see the attachment of nitro group to the benzene ring destroy the aromaticity. That means the molecule becomes less stable. So it destroys the aromaticity. But this complex is having the resonating structure and 3 resonating structure, and this 4th structure is the hybrid structure of this resonating structure. And then in 3rd step, this proton will abstracted by this conjugated base to give the final product nitrobenzene. So this is how this nitrobenzene can be takes place. Next reaction is next reaction is the halogenation. Halogenation reaction is the electrophilic substitution reaction. So 1 or 2 hydrogen can be substituted by halogen or halogen atoms. So 3 halogen cannot undergo these halogenation reactions. So in these reactions we have to use the Lewis acid catalyst to make this reaction happen. Okay. So when benzene can react with chlorine, for example, in the presence of AlCl3 or FeCl3, Lewis acid, which gives rise to chlorobenzene. So this is the general reaction. This is the reaction of halogenation. This is the chlorination reaction. When benzene reacts with chlorine in the presence of AlCl3 or FeCl3. So you can use any one of them, a Lewis acid catalyst, to generate this chlorobenzene as a substituted product. Okay, so let's see the mechanism. The mechanism for this particular halogenation reaction is similar as the mechanism for the nitration of benzene. So in the first step, step 1, this Lewis acid reacts with this chlorine to give the species species we can call it the 1. Okay. So in the first step we will get these species. In the second step, step 2, benzene will species So when benzene attacks at this chlorine, so this bond will get open like this, plus this complex, we will get this complex. Okay. In the step 3, so this hydrogen will get eliminated. So since we have this chloride ion plus Cl3, so we will get HCl plus AlCl3. So our substituted chlorobenzene along with this Lewis acid catalyst. So this is how this halogenation reaction is. In the first step, this Lewis acid will react with chlorine to give this species, and then this species will attack on the benzene ring to give this complex. Okay, and finally from this complex this hydrogen get eliminated. So to give this substituted product. And one thing is, when this benzene get attacked by this species, okay, this reaction is slow state, and this is the fast state. Next reaction is the sulfonation. So when benzene is reacted with fuming sulfuric acid, that is oleum, that is mixture of sulfuric acid and sulfur trioxide, which gives the benzene sulfonic acid. H2SO4 and SO3, 30 minutes. So in this reaction, the one hydrogen will get replaced with this sulfur trioxide electrophile. Okay. So SO3H, this is the product, benzene sulfonic acid. So this reaction will completed within 30 minutes. Okay, when benzene reacted with fuming sulfuric acid, which gives rise to benzene sulfonic acid,